Okay, and this is part two. We're going to go ahead and continue by looking at the horizontal asymptotes if they exist for this particular function. And what I'm going to go ahead and do, again, is take a look at the exponents of the numerator being 1. The degree really just in that numerator there is 1. And the degree here in the denominator also 1. So if I look at what n and what m are, n being 1, m being 1, and of course n equal to m, speaks to the second option there for us. If n is equal to m, then y equals a sub n over b sub m, the coefficient of the numerator, leading coefficient that is, divided by the leading coefficient of the denominator, and that being, of course, the horizontal asymptote. So we'll go ahead and continue here by noting that where y will be equal to 2 over 4, the coefficients, or 1/2. So the horizontal asymptote for this function, y equals 1/2. Okay. I'm not going to graph every single problem here today, but what I will do is, at least not by hand, but what I will do is go ahead and take a look on the graphing calculator what this graph looks like. And we'll go ahead in parentheses, 2x plus 5, parentheses, divided by a quantity 4x minus 6. So we'll go ahead and zoom 6. Taking a look here now, here comes your first branch of your hyperbola, and here comes your second branch. There is a horizontal asymptote here at y equals 1/2. So y will never technically equal a half, but it'll only be above it or below it. And you'll have a vertical asymptote here at 1.5 or 3/2. X can never be equal to that, only to the left and to the right, as you see. I do want to finish this particular problem, though, with domain and range, and I will kind of bounce back to the graphing calculator if I need to. The domain, again, will be really all numbers except for, or limited to possibly, and we are here by what x is. In this case, x can't be 3/2. So I'm going to say negative infinity. I'm going to go back to my graph. X approaches 3/2, it looks like, from the left as well as from the right, but never technically gets there. So we'll say 3/2, parentheses, and then in union with 3/2 to infinity. As far as the range goes, that's going to be very similar. And of course, in this respect, though, we're looking at y values never being equal to technically 1/2. So we're limited in that regard. And then as far as the y's, we go negative infinity to 1/2 in union with 1/2 to infinity. So the values are only above and below 1/2, never equal to. And the graph again speaks to that. Moving on to the next page. So this next function, h of x equals x squared all over x plus 1. We'll jump in here looking at what n and m are. N is 2, the numerator degree or exponent, highest exponent, and then the denominator 1. And of course, because n is greater than m, we haven't seen this yet, but that's going to help us looking back, though, at the second option of the two from the previous page. We see that n is greater than m, then there is technically no horizontal asymptote. Now, there will be a slant asymptote. We're not going to concern ourselves with that in this section, but as a kind of preview, so to speak, of what's to come, it will, though, have a slant asymptote. Because I already answered that, basically, go ahead and say 2c, no horizontal asymptote. We will, like before, take the denominator, set it equal to 0. Again, we know the denominator can't be 0, but we're saying here, that x can't equal negative 1. But when we say what the vertical asymptote is, we say x is equal to negative 1, and we're limited in that regard in terms of x. We'll go ahead and graph this on the calculator, not by hand again. And we'll see here we've got x squared over quantity x plus 1, graph, and here comes my couple of branches, which is, again, we're going to refer to as a hyperbola. Now, we've only seen hyperbolas thus far, but we are going to see a variety of different kinds of rational functions with maybe multiple vertical asymptotes, horizontal asymptote, still will only be singular, and then maybe a slant asymptote. This particular function does have a slant asymptote. We're not going to find it, but we're going to continue by looking at domain and range. Let's talk about it. Domain and range. Yet again, domain will be as easy as deciphering what x can and cannot be. The vertical asymptote, as we discussed, is at x equals -1. So that'll be a good point to start at. The domain being negative infinity to -1, and then parentheses, of course, in union with -1 to infinity. So we know we can have everything but -1. Now the range, on the other hand, as you can see, we don't have any values in the range, or y values, I should say, in between these two branches. So we're going to go ahead and find the minimum point here. We're going to find the maximum point there. And to do so, we'll hit second trace. Let's find the minimum first. I'll hit option number 3. And if you guys can just please scroll to the right with me. Mine happened to pop up on the bottom curve, which is fine. But I scroll to the right, and it actually jumps over to the other curve. I hit enter for left bound. Scroll to the right. I hit enter for right bound, and then enter one more time. The calculator is, if you guys recall in various other problems we've done, the calculator is not as accurate sometimes as it can be. This value right here, though, is so close to 0. That's what we're going to interpret it as well as this particular value. So 0, 0 is the minimum. I'm going to write that off to the side here. I know I have a min point of 0, 0. And I'm also going to highlight the max point. So if we, again, hit second trace, this time option number 4, scroll to the left. I want to get over to that bottom curve. I'm noticing there, here comes my cursor, scrolling to the left of the max. I'm good there for my left bound, hit enter. Scroll to the right. Here's my right bound, hit enter. And then enter one more time. And that's definitely very, very accurate. So -2, -4 is the max. Because when coming up with the range, we only want to consider y values. We can see this curve is below the max, but includes the max of -4. So we'll say negative infinity to -4 with a bracket, because it includes it, like I said. And then the graph jumps up to this particular point, y value, which is 0, bracket. It includes it, like I said, and that goes up to infinity. The next example, I'm going to go ahead and take a look at, is an application problem, example 3. It says, the Game Commission has determined that if 500 deer are introduced to a preserve, the population at any time t in months is given as such. Okay, so what I'll do here is I'll take the equation and I'll rewrite it as such. I'll say 350t plus 500 all over 0.2t plus 1. And the reason I'm doing this is so that I can easily distinguish between my n and my m values. Everything is kind of written nicely in standard form. It is. So I know n is 1, m is 1, n equals m. So then I can easily say, well, gosh, my first option to kind of go through would be to take my denominator, set it equal to 0. I'm finding my vertical asymptote. Subtract 1, divide by 0.2, which ends up being -5. So my vertical asymptote is at -5. It will turn out to not be of importance on this particular problem because we're talking about t in months, unless we went back prior to whatever year we're talking about, which we're not here. It won't be relevant. So I'm going to go ahead and then find, of course, my horizontal asymptote. When, of course, n is equal to m, we simply say that y, the horizontal asymptote, is equal to the numerator leading coefficient divided by the denominator leading coefficient. And in this instance, we get 1,750. So my horizontal asymptote is y equals 1,750. So what we'll do now is we'll go ahead and take a look at the graph of this. And I'll do that on the graphing calculator, typing in the quantity 350x plus 500 over quantity 0.2x plus 1. So we've got this. I'll zoom Well, I could zoom 6. I'm going to actually retract that. And technically, if we go to our window, we're going to say 0 for the x-min. We're going to start at a t value or x-min value of 0. I'm going to stretch that to 100. I could maybe cut that in half, but I'm going to get a nice visual of this. So y-min, I'll say 0. Can't have negative deer. That doesn't make any sense whatsoever. The y-max, because I already know what my horizontal asymptote is going to be, I'm going to stretch it out to 2,000. I think that should be perfectly good to get a good picture. Hit your graph button. Here comes your curve. Now, realistically speaking, and yes, this is part of a hyperbola, realistically speaking, that is really all that we want. We only want a first quadrant representation. If this wasn't a word problem context, we would want obviously more. We didn't even include the vertical asymptote, which is somewhere here. Vertical asymptote, of course, not being a positive value, and really we're not going to kind of go back before the t-value interpretation of t equals 0. We're going to stick with the first quadrant only. I'm going to go ahead and graph this by hand. We'll start with 0, and at 100, of course, this being t, this being n, and we'll say that 2,000 I'm stretching to for the quantity of deer. And then what we're going to go ahead and do is, going back to the graph, we can see that it takes shape as such. We can go ahead and graph. Now, I made sure that I limited myself in the vertical manner, particularly because we have a horizontal asymptote here of 1,750. Now, if we go ahead and take a look at answering the final question, what is the carrying capacity of the preserve? The carrying capacity of the preserve will simply be whatever the horizontal asymptote dictates. So, as you can see, the carrying capacity is basically limiting us to 1,750 deer. That is the carrying capacity.